Okay, so we're going to be looking at some percentiles today. Again, remember percentiles are where does this guy fall, such that, like, if I was this guy here, what percent of the population are below him? That's the idea. See that? What percent are below him? And so there are several recipes for this. Okay, there's several of them, and so I'm gonna show you the one that your book has. If you are like a lot of kids, Groom, I prefer to learn from, bobthebuildermathematics.com, and they use a different recipe than you. Okay, that's true. So it's just like anything else. I was looking up not me, but you were looking up, let's say, a lemon meringue pie recipe. Every single lemon meringue pie recipe will have the following things. You must separate the eggs and the whites. You're going to beat the whites until they are stiff. That's a fact. You're going to use a lot of sugar, lemon juice. That's all the things they have in common. 100%. Now, some of them add some different things to the meringue to make it fluffier. Okay. Some of them add a little different into the custardy part to make it different. All right, more lemony, more this, more that, whatever. I use less sugar, you use more sugar, whatever. I don't know, someone's diabetic uses, what do you call that? Splenda or something. I guess, right? Whatever. The point is they're all going to make basically a lemon meringue pie. So my point is that when you look up a recipe to find percentiles, what you will find is there are several different ones out there. This is the one that your book uses. Okay? So that's the one they use. So in our case, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. N equals 12 for us. Okay? So in our problem, it's going to be I is going to equal 13 times whatever the percentile I'm looking for is, divided by 100. So let's say you want the 70th percentile. Well, that's cool. So if I take that, I'm just going to go 13 times 70 over 100. Now, of course, Cosette's like, Groom, couldn't you just done 13 times 0.7? Yeah, yes, dear. Good job. So in either case, that's 9.1. That's the 9.1th term. Yes? But wait, Groom, there's only 1, 2, 3, 4, 6, 7, 8, 9. There's only a ninth term, and then there's a 10th term. How do I find the 9.1th term? So what we do is this. Take the 9th term. And then we're going to add 0.1 times the difference between these two guys. Here's the 9th term. Here's the 10th term. The difference between them in this case is 3. So 19.3, we say, is the 70th percentile on this data set. Let's do another one. Let's say that you would like to find the 10th data set, the 10th percentile. By the way, if you say it's up here, you're an idiot. It clearly is down here somewhere. True dat? So, remember there were 13, well, it's 12 plus 1 is 13 times 0.1, or 13 times 10 over 100, either way. So it's the 1.3th term. Well, that doesn't make any sense. There's the first term, and there's the second term. So it's going to be the first term plus 0.3 times the difference, which is 1. So 2.3 is your 10th percentile. Now we can do this all day long. Grim, what if there were, I don't know, what if there were 1,000 data points? Okay, cool. And let's say there were 999. I do that math in my head easier. How about that? 999 data points. Blue, 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 blue. Look at them all. Judas Priest. Look at them all. Look at them. Mr. Groom, I would like to have the 40th percentile. Oh, cool. So 99 plus 1 times 40 over 100. In other words, that's 1,000 times 0.4 is the 400th term. Because it came out even, we're going to go exactly to the 400th term. So n equals 400. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 400. That guy right there will be your guy. Okay, it's that easy. Okay, the n plus 1, what that does is it makes sure that there's some underneath of you. For instance, if I asked you for anything below 10, all right, single-digit percentiles. If you just put in the number, what you'd find is it would be basically barely off of the bottom term, in other words, or the 100th percentile, or not. Point is, if you have it in there, what it does, it allows us not to ever have 0 percentile. It allows us never to have a 100th percentile, the n+1 part of the formula. Okay. Now, let me show you what Excel looks like, or Google Sheets rather. Let me pull this one up here. So I did this one earlier, except for I'm going to delete that because I don't remember what I was doing. Well, that's not true. I remember what I was typing in. So again, Google Sheets uses a different recipe, which is told. Come on, damn it! Go away. Okay, now. So here's my data set, and there are 13 of them in this data set, yes? Okay, so if we were doing it like before, we would say equals 13 plus 1 is 14 times, let's say I want the 60th percentile, so 60 divided by 100. So I get the 8.4th term, so that would be equals 31, right? Plus 0.4 times. Now the difference between 31 and 31 is what? Oh, 0. Oh, that's hot. So what did I say? The 40th percentile? I can't remember what I said. So the 40th percentile, no, the 60th percentile should be 31. Okay? And you're like, well, can Excel do this for me? Yes, equals percentile. And by the way, if this doesn't show up, by the way, this part right here, you're like, Groom, it doesn't tell me what to do. Click on the question mark. And it wants you to highlight the data. So here it is, comma, and then type in the percentile you want, so 0.6. And it comes back 31. Yay, we agree on one. Woohoo! But let's say we don't agree. Let's say, in fact, instead, let's say we want the 20th percentile. Let's see if we agree. So that would be the 2.8th term. So that'd be the second term, so 19 plus 0.8 times the difference between the second term and the third term, which is 2. And so we would say that it's 20.6. But look what the computer probably is going to say, something different, my guess. Oh, well, it came out with 23. Wait, what did I do? Wait, what did I do here? Right. So we're close. Yes. Are we the same? No, we're not the same. Okay. So we're in the ballpark, but we're not the same. Okay. So that's how Excel is going to do it, or Google Sheets is going to do it. So just be aware that just be aware that that's the thing. Okay. So another method that another book that I used to teach out of used to tell us was this: you go equals the number of terms there are. So we would just go, we would just say, so in our case they're n, yes, and we take n times p over 100, right? And then we would do it that way. And so, and if it was 13 times 0.7, we'd get 9.1, and we would round that up to 10. That's what we would do. Okay, that's what we used to do when I was a kid. Okay, we take the 10th term. Okay, that's a different method. You don't need to know that. That's just how we used to do. And but the goofy one about this one is, well, what if you had the fifth? Not the fifth. Let's say there was 14 of them, and you wanted the 50th percentile. Well, you would get 7. But the problem with that is that's not directly in the middle. And so what we'd do is we would take n times 0.5. If this equaled a whole number, this is a whole number, what we would do is take that one and then the next one, and we would average them. Okay, and that's probably how you were taught back in the day to find the median, which we're going to do in a few minutes. Okay, because the median has a special name. He's a special percentile. Okay, now I say that because there are several ways to do these guys. I don't like this other one as well as the one I grew up doing, so I'm going to go ahead and do another one here, but let's just say that was the case. Suppose you had 999 of these guys, and you wanted the 70th percentile. According to this formula, you do 9999 plus 1 times 7.70, and that would end up being the 700th term, right? You just count over from the lowest all the way up to the 700th term. Ta-da! There's your 70th percentile. It's that easy. Okay. So just be aware of that. Not very hard to do, though. Now, what about some special percentiles? So what about the 50th percentile? Well, that has a name. It's actually referred to as the median. Okay. Now let's see if these recipes work for the median. So for instance, 2, 3, 7, 9, 12, 14, 17. What's the median? Well, that guy is. Okay. Well, how'd you do that? Well, I did that because why? Well, because I know Mrs. So-and-so said it's the middle number if they're odd, right? Remember that back in the day? But here we have, there are 7 data points, 7 plus 1, yes, times 0.5. And so 8 times 0.5 is 4. In other words, it's the 4th term. Piece of cake, huh? Piece of cake. What if there were another point? Okay, well now there are 8 terms, yes? Now there's 8, so 8 plus 1 is 9 times 0.5 is, well, I want the 4.5 term. Okay, well, where is that? Well, 1, 2, 3, 4. So 9 plus half of the difference between here. So it'd be 10.5. But what is 10.5? It is the average of the middle two, right? Well, that is exactly what Mrs. So-and-so told us back in the day. Do you remember that? Mrs. So-and-so in 3rd grade, let's call her Mrs. Josephine. What a great gal. Anyway, she told us that if you had an odd number, that the middle one is the median. Check, it works on the top one. If she said there was an odd or an even number of them, you take the middle two and you average them. Well, this is exactly what was happening with this formula. So it works for both of those. That's key because our median is our biggest guy that we care about. Now, we also, in this class, care about the 25th and the 75th percentiles. Okay. Oops, percentiles. Yes, percentiles. Yeah, look at us. Nice. So these have names. So it turns out this is the first quartile. The median, of course, the median is the second quartile. Yes, because that's 2 quarts is a half, right? And then the third quartile is the 75th percentile. Okay, they are the same. So in other words, oftentimes I want to break my data into quarters. Okay, that's what I want to do. And so to do that, okay, well, we got to figure it out. So let's see if this works. 2, 4, 5, 6, 7, 8. Okay, we'll start with this one. Yes, this is 9 of them. 1, 2, 3, 4, 5. For God's sakes, there's your median or your 50th percentile. Correct? Yes? Now, how do I find the 25th percentile? Well, exactly like you think. So there's 9 of them. So 10 times 0.25 is the 2.5 term. Well, there's no 2.5 term. So we're going to take the second term, 4, plus half of the difference between these guys. Well, that's a difference of 5. So half of that is 2.5. So 6.5. But what is 6.5? 6.5 is the average, yes, between those two numbers. That's a fact. Now, listen, I'm no rocket surgeon here, but I do know that the average of these guys will be quartile 3. How do I know that? It's called symmetry, dog. It's called symmetry. So I could just skip to 22 plus 26 over 2, which is 24. Yes. Or I could do the actual math. So 10 times 0.75 is the 7.5th term, right? But the 7.5 term is the 7th term plus half of the difference between them. Well, the difference is 4, so half of that is 2, so 24 is your answer. Okay? Meaning that if I draw a line here, there's a quarter of my data. If I draw a line here, there's a quarter of my data. This 13 being right on the cusp, so don't count him. There's a quarter of my data, and there's a quarter of my data. You with me? And I can break it up. If you were in the top 25 percentile or the third quartile, and after I get done testing you, then yay, you've learned stuff. Woohoo! And then if you're in the lower, yeah, I kind of suck. Or if you're in the middle quartile right there, okay, if I look at that as middle 50%, a lot of times that's the part I really want to focus on. Now, the middle 50%, again, is another way of showing, hey, where is the middle? It's where is the middle on this stuff a little better, right? And so we will be looking at that in tomorrow because we're going to actually deal some more with these guys. But let me do another example here. Let's do one that has an even number of them. They're not all even numbers, by the way. I just started doing it because I'm an idiot. Boom, boom, boom. Bob's your uncle, yes? There are 5 of them, or 10 of them, rather. So the average of these two, which is 18, would be your median, or if you prefer, Q2, okay? That's the rule. It's always been the rule. It'll always be the rule. So it's 10 plus 1. If you're going to follow this new rule, though, it's the 5.5 term. Well, what does that mean? It means the 5th term plus half of the difference. So it's the 5th term, not the number 5. So it's 17 plus 1 is 18. Well, what about if I want the 25th percentile? 10 plus 1 times 0.5 is, it's 11 divided by, oops, times 25. Come on, pay attention, stupid. It's 11 times 0.25. And you get the 2.75 term. So I'm going to start with the number 2. Yes. Plus 0.75 times the difference. So that's a difference of 4. So 2 plus 3, damn it, it's not the number 2, it's the second term. So 6 plus 3 is 9. That guy right there should be our guy, yes? Now, if I'm going to do the 75th percentile, which is quartile 3, 11 times 0.75, I feel a little embarrassed, but I'm going to do it anyways, I don't care, times 0.75 is 8.25. So in other words, we're going to take the 8th term, which is him, 29, plus a quarter of the difference between these two. Well, a quarter of the difference is 2. A quarter of that's a half, so 29 and a half. That's Q3. Again, there are several ways to do this. Okay? The older one I showed you earlier, what we'd end up doing is when we multiplied it out, we would just always average those guys and just average those guys. But it doesn't matter. We're in the same ballpark. Okay? This is sometimes a slightly more accurate version. But again, they are the same basic place. Quartile 1, Q1, Q3. Okay, and of course the median is always Q2. Okay, that's what we're going to be doing. And so on Tuesday, yes, on Tuesday, we're going to be getting into box plots, and we're going to be using the quartiles on those. We're going to be also putting a number, or quantifying, we're going to be quantifying how weird somebody has to be an outlier, okay? And so we'll be looking at that, but we'll be using the quartiles in order to do that, because what it'll say is it'll be like, is this guy an outlier, or identify the outliers, okay? Well, what it's going to end up being is how far out from the middle are you? That's the big deal, yes? Because if there's a middle group and you're far enough out, that's pretty weird. So we're going to take a look at that tomorrow. And we're going to see about how to do some of these graphs in Excel, Google Sheets rather, and then we're also going to be looking at some data and using Excel or Google Sheets to analyze it, okay? So we're talking about that on tomorrow. But you can start doing the percentile homework in the book right now.